Good evening, sir.
Evening, sir. Yeah. Hello.
Yes, good evening.
Good
Am
evening,
I
sir.
very good evening?
Yes,
Am I
sir.
audible? Yeah.
Yes, sir.
Okay, so today we are going to complete this chapter that is the water, right?
Sir.
Yes, sir.
Okay, let me share first of all the screen.
Nitish, turn on your video.
1 second, I'll just take my book. You come and only write, the test.
Yes, I was gonna ask you the same thing. I am gonna
No
come
one
and
else
write.
is coming, bro. Only you and me again. Only you and me are coming to write the test. Ponguvel is sick and he might not come. Also, yes, Moon only
Bruh,
come at
how
4
is,
o'clock.
how is that every time there's a
Also, yes,
test,
Moon
Pongu will
Ra.
become sick there?
Also, yes, Moon.
Oh, yeah, yes, Moon.
Tarun said there will be no one at his house at that time.
So is this screen visible now?
Yes,
sir.
sir.
Okay.
Bruh, how come Pongu is always sick when exams come there?
I don't know.
Is there anybody who has not yet joined it?
So, two more people has to join, sir.
Yes, sir.
Which one?
Ponguvel and Tarun.
Pongu. Sir, I messaged Pongu, but I don't know. It's coming back.
Actually, today's
Didn't
class,
respond, sir.
it is very important because we will discuss very important points today, and we have to finish this unit today. Okay, I hope that you will focus on each and everything. We have just discussed the some terms like efflorescence, like we have already. Yeah, exactly. Now the next is what are desiccants. So have you heard this term desiccant?
No, sir.
Okay, let me write it here. Desiccants. Desiccant is they are in simple language. They are simply known as drying agents.
Okay.
Drying agents. So have you got it now? So they are simply those substances which will actually help in drying. That means they will actually remove moisture from other substances. So I will write the
Yes.
definition. I will write the definition. They are the substances
Yes, sir.
which remove moisture, from other substances. So I hope that you will today keep the speed a little bit fast.
Yes,
Writing
sir.
speed.
Yes, sir.
Okay, so I just wrote that these are the substances which remove moisture from other substances. So they are simply known as drying agents. That means they help in drying or desiccants. So let me give the example. For example, if I just talk of we are having calcium chloride, it is my one of the desiccator. That means whenever there is some moisture in anything, we just have this calcium chloride, it will just absorb, it will just remove the moisture from that. So this is my desiccant, or we can say it's a drying agent. Similarly, phosphorus pentaoxide, it's P2O5, it is also a drying agent. Similarly, calcium oxide, that's my quicklime, CaO, quicklime, it
Sir,
also
this
acts.
is
The
the
COH
drying agent,
twice,
sir.
right,
But
sir?
sir, this sir CaCl2 is the drying agent. But what is the absorbing agent? So that means something has to take chlorine from it, right, sir? From CaCl.
Actually, it absorbs the moisture. For example, have you sometimes seen that when we just take shoes from the market or any medicine which is in the bottle that contains some those packets, small packets. What are those? Those are actually those packets which will absorb
Yes, sir.
moisture
Yes,
there.
sir. Yes,
Exactly.
sir. Sir, like they put some powder in that packet and
Exactly.
they just
Okay,
keep it.
okay. I will tell you what is that powder. That is actually your silicon dioxide. That is known as silica gel. So that is your silica gel.
Yes, sir.
So that
Yes,
will
sir.
absorb moisture so that medicine will not get destroyed. That will not degrade. So you have to remember they are
So
your
these compounds they absorb moisture.
exactly, exactly. See, this sulfuric acid, this is very important. Sulfuric acid also absorbs moisture. So it is also a desiccant. It is sometimes asked in the exam that is sulfuric acid a desiccant? So you have to say yes, because it also absorbs moisture.
So if sulfuric acid is a absorbing, I mean a desiccant or a drying agent, why do we put it in water to make it more like
No, since it is an
very
acid.
more sharp?
See, since it is an acid, it is not it is not widely used. It is not mostly used. We use other desiccants like calcium oxide, like calcium chloride. Being acid is having its harmful effects. We know that it can
No,
affect
sir.
our
No,
skin.
sir.
Okay.
As I'm saying, as H2SO4 is a drying agent and it
Yeah.
absorbs moisture. Why
Right.
do we put H2SO4 in water for electrolysis to work? So it should absorb water, right?
Exactly. We put this what H2SO4 in water in order to make it a good conductor. See, actually, what happens there? If we just take this H2SO4 in water, it ionizes. It gives ion. It gives you H positive twice, and it gives you the sulfate ion. So because of these ions, water becomes good conductor. So that's why we are dissolving it in water.
Yeah, yes, sir. But why H2SO4 should absorb?
Yeah, it absorbs a little bit water. It is not absorbing so much amount of water. It absorbs a very little water. Got it? I think you
Yes,
are
sir.
facing the network issue.
So Sankat is facing network issues. So for me, it's
Ex-
clear, sir.
Okay, okay. So I hope that it will become soon correct. So shall I continue?
Yes, I guess.
So you
Sir,
had
are you
some,
there?
yeah, yeah, I'm here. So I was just saying
Sorry,
that
sir, I
this,
couldn't.
okay, okay.
Yes,
I will I will
yeah,
repeat. I'm just saying that this sulfuric acid, it is my desiccant, it is a drying
sir.
agent, it absorbs moisture, it removes moisture from other substances. So if you are just putting it in water, so that is only your one of the substance. You have to actually have such a substance in which there is little moisture that it can absorb. It will not absorb whole of the water.
Okay.
Yeah.
Yes,
So when
sir.
we put yeah, when we put it in water, it gives ions. So these ions make water a good conductor. So these are our desiccants. So you have to remember these examples.
Yes, sir.
Yes, sir.
Let's go ahead. Next, we have to see here that is actually the mass percentage and volume percentage. So let's see how to calculate mass percentage. Whenever we have any solution, we just calculate the mass percentage simply as a mass of solute, and we divide it by the mass of solution, and then we multiply it by 100, right?
Yes, sir.
Exactly, that will give you the mass percentage. So mass of solution, you will just multiply the whole thing with 100, so it will give you the mass percentage. For example, I will just give one of the question. For example, if I am just having 2 gram of NaCl in, let's say, 98 gram of
Sir, mass
water.
percentage is basically percent uh, what is this percentage thing, right, sir?
Composition.
But for liquids. Yeah.
Exactly, it is the percentage. It will just give you the concentration of solution. Just we have studied what is dilute solution, what is concentrated solution. So when you just calculate the mass percentage, you will get the idea that whether it is dilute, whether it is concentrated. For example, you
So
will
it'll
just
be
get
2.22.
Okay, let's solve this. So there are 2 gram of NaCl in 98 gram of water, and you have to calculate the mass percentage of solute. So how can you calculate mass percent
So it'll
of
be,
NaCl?
so the answer is 2.22.
Okay, I will write it here. It is actually mass of solute, that is here your 2, and mass of solute. Can you tell me the mass of solution here?
So 90
Uh,
grams or 2 plus 9,
990 grams, 90 grams. 2 plus
It is
92.
98 plus 2. Why I have multiplied it by 2? Can you tell me why?
It's 98, sir.
Oh, that's a 9. That's an 8. I thought that was a 0, sir.
It is 98, but it is only that of solvent, that is water, but you have to multiply it with the mass of the solution, isn't it? This is very important.
Yes.
Right?
It'll be
Yeah.
2, sir.
So when I just multiply it,
So it'll
It
be
will be
2 only,
100.
sir.
Yeah.
No, it'll be 2, da.
so into 100, so
No,
it will just,
100 and 100 will get
2.
cancelled, sir.
it will
Yes,
only
sir. It
come
will
up
be 2.
with 2. 0
It'll
0
be 2.
cut, it will be 2, yeah.
Yes, sir.
2%
You're saying
only.
the final answer. I was like 2, 2. What do you mean by 2?
Excuses for everything, da.
So
Actually, I'm not
Okay,
lying.
okay,
so
okay, okay. I believe you. I believe.
final answer will be 2. You have to remember that you have to just divide it by the mass of solution, not that of solvent. It was here the mass of solvent only. It was the your water. You have to first add mass of solvent and mass of solute, right? This is very important
Yes,
here.
sir.
Yes, sir.
Okay, then can you tell me how to calculate the volume percentage? This was the mass percentage. How to calculate the volume percentage?
Uh,
So volume of the solute by volume of solution into 100.
Exactly. So you will just write the volume of solute, that is actually given in ml milliliters, and you will divide it by the volume of solution, and you will then multiply it by 100, right?
yes, sir.
Yes, sir.
You write down this.
Pongwell said he was sick, sir. Like he had a very severe
Actually,
headache.
said to me,
That's the reason he didn't show.
Okay, no problem.
Yeah, he said.
I will then finally share these.
Tarun is normally, sir. I don't know why he didn't join. I think he forgot.
Okay, you just share then these pics, right? These
Yes.
notebooks
Sir, the
with
video
them.
will confirm.
Exactly. Okay, now tell me here, for example, if I am having, let's say, 20 ml alcohol, 20 ml of ethanol. Ethanol, it
100
is
and
an alcohol. In, let's say, it is your 60 ml of water. You have put it in 60 ml of water. So can you calculate the volume percentage of this one?
sure.
That is your volume.
So it'll be 25. It'll be 25.
Okay, I will write it here.
25
60.
milliliter. No?
So what you have to calculate? You have to calculate the volume
It will be
percentage
25,
of.
So
sir.
20 divided by 20 plus 60 into 100. So 20 divided by 80, which is
So that is
20
20 divided into
by 20 plus
1 by
6,
4.
right?
yeah,
Into 100.
after
Exactly.
0.25 and then into 100 it will give you 25
Hey,
25.
you did like that, Tada. I did 20 and 80. I made it 1 by 4 into 100. It will become
I mean
100
you
by
can do
4,
like that
25.
also.
2 4s are and 2 5s are, right?
Yes,
Yes,
sir.
sir.
4 5s are 20. 5 5s are 25. So it will be 25%, right?
Yes, sir.
Yes, sir.
So now tell me, if the volume percentage of ethanol is 25%, what will be the volume percentage of water? That will be 75.
75%.
75.
Exactly. Okay, so have you written down this? Shall I move to the next
Yes, sir.
page?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So next it was the mass percentage, volume percentage, and we have discussed what is desiccant. Then we will study about the solubility. So do you know what is solubility?
Yes, sir.
Sir, how well a
You,
solid can
you said
how
how well. Oh my. So you
Okay,
did say, sir. I just don't know why you said it.
I didn't
I will
say.
write it here.
You said
Solubility
I
actually means
yes,
it is the
amount of
maximum.
substance in grams which gets
Okay, I will
dissolved
write
in
it here.
100 grams of solvent.
It is the maximum amount of solute in grams.
Oh,
Maximum amount of solute in grams,
So we
maximum amount of
already
grams, yeah, that can be,
dissolved in 100 grams of solvent.
that can be dissolved in 100 gram of solvent, right?
Yes, sir. So we already wrote
Yeah,
this solubility amount of substance
Wait,
in
did we write
liquid.
this somewhere?
Yeah, we did this. That's what I'm
exactly.
saying. You said no.
Exactly. Okay, then tell me how to calculate this mathematically. So you can simply say that solubility, it will be equal to the mass.
Solute plus oh, like that. Okay.
Yeah, so you will write the mass of
The mass of
solute
solute divided
in
by
grams
100
divided
into
by the
100.
mass of solvent into 100, right?
So, but
Very,
that means every time the answer will be mass of solute only, no, sir. Because 100
yeah,
and 100 will get cancelled.
yeah, exactly. 100 and 100 will get cancelled. That is actually the mass of solid. For example, I just give you the example that if 36 gram of NaCl, it is just put in it in water, right? But you have to remember here that at a given temperature, because if we just change the temperature, solubility will also change, right?
Yes, sir.
Yes, I hope that you will write this complete definition. So it is the maximum amount of solute in grams that can be dissolved in 100 gram of solvent at a given temperature. Because when we change the temperature, solubility will also change. I will give you the examples. So 36 gram of NaCl, it can be dissolved in 100 gram of solvent, 100 gram of solvent at 25 degrees Celsius, right?
Yes, sir.
So this is the solubility of NaCl. But you have to remember that this solubility, it is actually affected by the temperature, and those factors are very important. And I hope that you will remember. So let us see the various cases. Case
So
number
we
first.
did this, sir. We did this, sir.
No, no,
No.
no. I will
No.
repeat it. It's very important. We will study the factors affecting solubility. That is the temperature effect. It is very important. See, actually, we are having some salts like NaCl. If we just increase the temperature, solubility will also increase, but it will increase
Increase.
slightly, slightly,
Yes.
slightly.
So you,
Okay,
you
Both are
taught us
directly
like
proportional.
36 grams can like fit in like 100 grams of solvent, and when it is increased to 25, more can fit 25 degrees Celsius.
No, 36 is the max.
exactly. 36
After
is
that
No,
will be
if you
super
increase the
saturated.
temperature, if you
okay,
increase the
okay, okay.
temperature
I
25
will write
degrees
it here.
Celsius.
I will repeat it here
If
that
we
if
increase the temperature, the grams will decrease. The
The
no grams
solubility will increase, yeah.
the solubility will increase. Why
no,
you
the
are not?
solubility will
25
increase,
degrees.
sir. The
Okay,
grams
okay. I
of
will tell you.
NaCl will decrease.
So if temperature is increased, if I will just increase here the temperature, solubility will also increase, but it will increase slightly. Do you understand? That means not too much, correct?
Sure.
Yes,
For
sir.
So
example,
solubility is directly proportional to temperature, sir. But like the grams
yes,
of NaCl will decrease when increase in temperature, right, sir?
no, that will not decrease, that will
No,
increase,
that won't.
that
It's
will
like if like
increase.
okay.
Okay, I will just give the example. For example, let's say I'm having 50 degrees Celsius. At 50 degrees Celsius, the solubility of NaCl, it will not be 36 gram. It may be, let's say, 37.5 gram. So it will increase. Solubility will increase.
So it becomes super saturated. No, wait, no.
Super saturated is that when actually saturated solution is cooled down. That
Yes.
at that time it
Oh.
becomes super saturated. I have already written down that. I hope that you will go through that. You
Yes,
will
sir. You
revise
wrote
that.
that. Yes, yes.
Exactly. So now here,
So
this is
that's
very
what I'm
important
saying.
that when we increase the temperature, solubility increases, but it increases slightly. That means very
Yes,
little.
sir.
Yes.
Now we are having another salt here. That is your actually that is your potassium nitrate is my salt. Potassium nitrate, similarly sodium nitrate. These are those salts. When we actually increase the temperature, we are having potassium bromide. In case of these salts, if temperature is increased, then solubility will also increase, and it will increase will be very high. So solubility increase will be very high. It will not be slight, it will be very high. So that means a lot of salt can be easily dissolved at very high temperature. So got it?
Yes,
This is
sir.
very important. Yeah, so that means if we are having potassium nitrate, this is my potassium sodium nitrate. This is my potassium bromide. If we increase the temperature, solubility increases, and the increase is very, very high. This is to be remembered. In
Right.
case of NaCl, the solubility increases,
Oh,
but it increases slightly.
yes,
Okay.
sir.
Okay. Then the next case is that we are having a salt like calcium sulfate. We are having salt like calcium sulfate. Now here, if temperature is increased, solubility will decrease. If temperature is increased, solubility will decrease. This is very important. Solubility decreases here.
So,
And then we are having next salt that is exceptional, that actually shows the anomalous solubility. Anomalous.
4 degrees
Sir,
Celsius.
is it
It won't
water, right?
change.
No, it is not. Anomalous solubility is actually shown by Glober salt. I hope you remember what is Glober
Oh,
salt.
yes, global salt is over one second. It's
What is that? Glober salt. Do you remember that?
Na2SO4 dot uh,
10 times
10H2O.
what? Yeah, 10 times what? So it is sodium sulfate decahydrate, right?
Yes,
Now see
Yes, sir.
what anomalous solubility it shows. First solubility increases and then solubility decreases after some time. So that means there is no any fixed criteria. So solubility first increases and then solubility decreases here. If we increase more and more temperature, then solubility decreases. So first, if we increase the temperature, solubility also increases. But
yes,
then after some time, if we increase the temperature further, then
Until,
solubility
sir, until which temperature will solubility increase?
a particular.
yeah, that is actually
It
nearly
is depend.
31 up to 31 degrees Celsius solubility increases, but after that solubility will decrease.
So
So
it's
this
different in
temperature,
different materials, right?
yeah, yeah. So it is actually you will remember that this temperature is known as transition temperature, right?
Yes,
You will
sir.
remember that it is known as transition temperature. Transition temperature means it is that temperature up to which first solubility increases and then solubility decreases, right?
Yes, sir.
Yes, sir.
Yes. So have you noted down this? Shall I move to the next page?
So the
Yes.
yes, sir.
So we have discussed the four cases. I will repeat. Number first is NaCl. If we increase the temperature, solubility will increase, but it will increase very less. Now, in case of potassium nitrate, sodium nitrate, potassium bromide, if we increase the temperature, solubility will increase. It will be very high increase there. And in case of calcium sulfate, this is very important because if we here increase the temperature, solubility will decrease. Got it?
Yes, sir.
Sir.
Yes. And in case of global salt, first temperature, by increasing temperature, solubility will increase. Then after some time, solubility will decrease. That temperature is known as transition temperature. It's 31 degrees Celsius.
Yes,
Got it?
sir.
Yes, sir.
Okay. So I will actually show it here that there is actually some curves obtained known as solubility curves.
So what?
Okay, I will show the peak in which actually
Solubility
the
curves.
solubility
That is the
curve.
that's
So tell me, is it visible on the screen?
yes, sir. Is this too?
Yes, sir. But can you zoom a bit, sir?
You can zoom by yourself there.
Okay, got it now.
Yes, sir.
Now tell me here, we have discussed the four cases. So tell me, this is your potassium nitrate and sodium nitrate. You can see that curve increases very much. There is very much increase in the solubility, right?
Yes, sir.
Yes, sir.
And in case of sodium chloride, here it is the sodium chloride. You can see it here. In case of
Yes, sir. I
sodium
can see some
chloride,
yellow.
yellow, exactly, exactly. Now tell me, the solubility increase, it is very less. It is slight
Very
increase,
less.
right?
Yes,
Right.
sir.
Yes,
And in
sir.
case of calcium sulfate, you
Sir,
can see that
potassium.
it,
Transition. It's like a
yeah.
Yes, sir.
transition, sir.
In case of
Sir,
calcium
it is
sulfate,
a anomalous
Anomalous
solubility,
temp.
sir.
Anomalous solubility.
anomalous is not shown here in this picture. Anomalous is not shown. So anomalous will be
No,
what?
sir. Calcium sulfate until 60 degrees it's going up, and from 60 it's coming down, right, sir?
Calcium sulfate, it decreases. Yeah, it decreases here. Calcium sulfate, it is magar, it is hydrated one. Yeah, this is very important. Hydrated calcium sulfate, it also shows the anomalous, right?
Yes, sir.
Hydrated.
Yes, sir.
I hope you remember the hydrated and anhydrous salts, isn't it?
Yes, sir. Yes, sir.
Yes,
Exactly.
sir.
Okay, I hope that you can take the screenshot of this picture. This is very important, known
See,
as
I
solubility.
took it.
Okay,
I
so
took
shall I
it.
move to the next page?
Yes, sir.
Yes, sir.
Okay, so now tell me that here we have discussed the
Sir,
effect
can
of
you
temperature.
please, sir, can you
Yeah,
please flip your screen, sir? It's very small.
I have already, it is in the,
So just make it straight and flip it again, sir.
okay, wait. So is it now fine?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay, so tell me now, it was the solubility. Then we have to study about, mm, we have to study about the hot water. I hope that we have
Sir, we
discussed
did,
it
sir.
already.
So
Yes,
we
sir.
did
We
it,
We
did
did,
sir.
it,
We
sir.
did it, sir.
Water which
but
does not lather with.
yeah, exactly. But can you tell me what is temporary hardness and what is permanent hardness?
We didn't do that.
We didn't do that, sir. We didn't do that.
Okay, first of all, can you repeat again that why water is hard? It is because of which
It's the
salts?
presence of salts of calcium and salts of magnesium.
Yes, sir.
Exactly. But which salt is? There is some criteria. Which salts?
Salts, calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate, calcium calcium bicarbonate, and magnesium bicarbonate.
Exactly. Okay, then let me write here. There are two types of hardness. One is known as temporary hardness. Temporary hardness. So temporary hardness of water, it is actually due to the presence of bicarbonates of calcium and magnesium. Due to bicarbonates of bicarbonates of calcium and magnesium. So that means if we are having any water which contains calcium bicarbonate, that is CaHCO3 whole twice,
Oh yeah, yeah, okay, nothing.
magnesium bicarbonate, that is MgHCO3 whole twice. So these salts will be your these this type of water which contains these two salts, that means that salt will be, that water will be your temporarily hard. So temporary hardness, it is due to the presence of bicarbonates of calcium and magnesium. Now, can you tell me how to remove this temporary hardness? This is very important. How to remove this temporary hardness? Can anybody tell me?
We do.
By removing the bicarbonates, but as
Now, what is the actual method that how you can remove this temporary hardness?
Heat
That's actually
temperature.
by boiling. By boiling. I hope that you
Oh,
have
that's
seen
right.
that. Yeah, sometimes in the winter, what we do when we have to wash the clothes, we take the warm water. Why we take the warm water? Because in order to remove
Easier to
this
lather.
temporary yes, so that it will easily produce the lather. Exactly. So I will write that temporary hardness, it is removed by boiling. Temporary hardness is removed
so we
by
can
boiling.
also use double displacement, sir.
Is
That's you
removed
get
by
by boiling.
in case of temporary hardness, you have not use any other chemical method. You have just to boil it simply. Temporary hardness, it is removed by boiling. Now, can you tell me
Yes,
what happens actually due to boiling?
sir.
What
We can
happens due
also
to
do
boiling?
it by double decomposition, right, sir? Because magnesium is in the reactivity table, and we do it with some other element higher than magnesium. It
Double
will
decomposition.
like sorry, double
Double
displacement.
displacement, double displacement. Yeah, you can also do that, but this is effort. This is very simple. We have not to do any kind of reaction. We will just take this, let's say,
Yeah, but
temporary water.
we drink like hard water, right? So because it has all the minerals and
Yes, it
everything.
has all the minerals.
Exactly.
Sir, but
I will,
why do we boil water and drink it, sir?
The
because
germs
in
to
order to
be
kill the germs, in order to kill the
So
germs,
what do we
um,
accidentally remove the minerals also, sir?
no, by boiling,
in
minerals will not get lost. Minerals will be still there.
Okay.
Okay. Now, first tell me here that if I'm having this, this is my temporarily hot water, right? Temporary hot
Yes,
water.
sir.
Because
Yes,
temporary
sir.
hot water, it contains your magnesium bicarbonate. Now, when you just boil it, when you just heat it, what will happen actually? It will
The
just get converted.
magnesium and bicarbonate. Or,
It will just get converted to magnesium carbonate,
oh, other hydrogen. Okay.
and then
Yeah,
water,
that's true.
and then carbon dioxide. Is it now balanced? Can you check it out?
Yes, sir. It's bad. No,
Sir,
it's
it's not
not.
balanced.
Yes,
It's
yes,
not
sir.
balanced.
Balance.
It's
It's
not. It's
balanced.
not.
It is.
It is
Oh, it's
balanced.
not.
It is
Okay.
already
No, sir.
balanced.
It's not balanced.
It
It's
is.
not
It is.
balanced.
It,
It is
Wait,
balanced.
wait.
sir.
It is
How?
balanced, sir. Hey, you. It's balanced, sir.
Oh, it is okay. 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 Okay.
Yeah, it is
What?
balanced.
What?
So now tell me, we have what we have got on boiling. It gets converted to magnesium carbonate. Now tell me, is this responsible for the hardness? No, not at all, isn't it?
No, sir.
So that is why it is always preferred that whenever we have temporary hot water, we will just boil it so that its hardness will get removed. Similarly, if you are having the calcium bicarbonate, what will happen? So can you write the reaction yourself?
So calcium carbonate plus water plus carbon dioxide.
Exactly. Same reaction will take place. So that means your
Yes, sir.
water will be now soft water, because this is now your soft water, right?
Yes, sir.
Yes, sir.
This is very important. I hope you will remember it, that whenever we have temporary hot water, we will just boil it. It will get converted to the soft water. Got it?
Yes,
Yes,
sir.
sir.
Then we are having permanent hardness. So let me write on the next page. First, tell me, have you written down this?
It's almost finished once again.
Almost done, sir.
Okay.
Finished, sir.
Finish, sir.
Okay. So let me write here the permanent hardness. Next type is known as permanent hardness. So permanent hardness of water, it is actually due to the chlorides and
Salt.
sulfates of
Salt.
calcium and magnesium.
Sorry, sir.
Salts of calcium and carbonate.
Due
I
to
mean calcium
chlorides
and magnesium.
and
No,
sulfates.
calcium and magnesium is
I
temporary
said
hardness, sir.
salts of calcium and magnesium.
Okay. Wait, that is okay.
Permanent hardness,
It
right?
is, it is very easy to remember that in case of temporary hardness, there was bicarbonates
By
of calcium and magnesium. But in case of permanent hardness, it is the chlorides and sulfates of calcium and magnesium.
so
Got it?
basically salts of calcium and magnesium.
But in both these, there is calcium and magnesium salt. What is the difference? The difference is that in case of temporary hardness, it is the bicarbonate of calcium and magnesium. But in case of permanent hardness, it is the calcium chloride. It is the magnesium chloride. Similarly, it is the
Yes,
Sir,
sir.
calcium sulfate.
we can make permanent hardness also into temporary hardness, right? So like magnesium is a
Exactly.
part of the reactivity table, and we can
Exactly.
displace it, right, sir?
Simply, if we are having a temporary hardness, if we just add the chloride ion, similarly the sulfate ion, it will just become permanent hard. Exactly. Now question is that
No,
how
sir,
to remove.
I'm saying we can make permanent hardness also into temporary, because magnesium is a part of the reactivity table, and we can like double
See, it's not a
displacement. We can
bicarbonate.
use.
Magnesium is not the reason.
See, actually, magnesium and calcium, they are highly reactive metals. You cannot displace these. You cannot do the displacement reaction here. That's why we are just, and that is why I told that in case of temporary hardness, we just remove it by boiling. And in case of permanent hardness, we just remove it by simply adding washing soda. Do you
Sir,
know what
but
is
we can
washing?
displace magnesium.
Yeah, yeah.
Sir, we can use magnesium. We can use potassium instead of to displace magnesium, right, sir? Because
But
potassium is
potassium, it is
reactive.
highly reactive. When potassium you put in it in water, the reaction is highly exothermic. You cannot use that as it is.
Okay. Yes, sir.
So washing soda has sodium carbonate decahydrate, sir.
Exactly. That can be used here. Washing soda can be used to remove the permanent hardness. Okay, let me write it here. So permanent hardness is removed by adding washing soda to it. So I hope you remember
Why do
this
we call
washing.
it permanent hardness, sir?
Yeah, because it cannot be removed by boiling. Temporary can be easily removed by boiling, but you cannot remove this permanent hardness by boiling. So that's why it's permanent hard. So that's why you have to use any chemical in order to make it soft. So that's why we call it
We,
as permanent.
we say permanent markers that we can still erase
Exactly.
them there.
We are having the temporary and permanent markers. So same is the case. So permanent hardness is removed by adding washing soda. So can you tell me what is washing soda?
So sodium carbonate decahydrate,
Exactly.
Na2CO3.
Sodium carbonate decahydrate is used in order to remove the permanent hardness, right?
Yes, sir.
Yes, sir.
Okay, now tell me what will be the reaction, how it will actually get removed. Okay, I will write the reaction here. For example, if we are having a hard water, permanent hard water, so that means it will contain calcium chloride. Let's say calcium chloride. It is my hard water, right? So
Yes,
if I'm
sir.
just putting washing soda, so can I write washing soda like this, Na2CO3?
Yes,
Because
sir.
Yes, sir.
water,
Mm,
because these water of crystallization, they actually do not take part in the reaction. So that's why I'm
oh,
not
yeah.
Yes,
writing
sir.
it.
Okay, okay.
Okay, okay. Okay, now tell me what will happen. What it will result in the formation
CaCO3
of
and
Sir, Na will
NaCl.
it will become NaCl and CaNO3 because
CaCO3, that is calcium carbonate,
sorry,
right? So,
CaCl.
Yes,
so
CaCl.
sir.
this, yeah, so this water is now your soft water. Got it?
Yes, sir. I'm saying yeah. Okay, I get it. Sorry.
Yeah, yeah, it is very
So
easy.
calcium carbonate. Okay, nothing.
Yeah, yeah, due to this calcium carbonate, there isn't any hardness. Hardness is because of bicarbonate. That is very, very important.
So calcium carbonate is a base, right?
Yeah, it is a basic
Yes,
carbonate.
calcium carbonate is a base.
Okay, now tell me that if hot water contains magnesium sulfate, then what will be the reaction with this washing soda?
What?
MgCO3 twice. Oh no,
If I
MgCO3 plus
Yeah, exactly.
Sir,
It will become
or Na
MgCO3
yeah.
Na2SO4.
MgCO3 twice and Na.
MgCO3 is twice, sir.
Okay.
It's
I have already
CO3 is
said
also
that
Not
it
two,
is
right,
da.
sir.
The
more
CO3 is
and
two
MgCO3
only.
is two, right?
it is
CO3 is two.
MgCO3. No, no,
So
not
No,
here
that's
too.
it, sir.
CO3 too. Sir, it's CO3 too, sir. It's CO3 too.
No,
What?
No,
no, it's
no, no.
CO3 only, sir. CO3
Only
only,
one.
da.
Okay, I will write it here that magnesium its valency is 2. Do you remember that? Its valency is
Yes,
2. And what is the
CO3 is
valency of
also
this
two minus.
carbon?
Oh, sorry. Okay, they
Two
cancel out. They
minus.
cancel out.
You
Bicarbonate
can
is only one minus.
exactly.
Okay, sorry.
So, have you got it that how to remove the temporary hardness and how to remove the permanent hardness?
Yes.
This is very important. Exactly.
Sir.
So, okay, no.
Have you noted down this?
So when we like
Last.
in temporary hardness, when we are writing the equation or writing the yeah, equation, you have to write the delta symbol in the top of the arrow mark, right? So
In case
because
of
we are
heat, you will
boiling.
write the delta sign. In case of heat, in chemistry, heat is represented by this delta.
Yes,
When
sir.
we write examples of temporary removing temporary hardness, we can write MgSCO3 twice, delta gives
Yeah, I have
like
We,
that
already.
we can consider.
we have to write delta. We have to write delta.
Yeah, yeah, you have to write the delta. Delta
Oh,
represents
I
the
didn't
heat. I have shown it here.
yes, sir. So
Exactly.
here no
Okay.
heat
Sir, done,
needed
sir.
right, sir, for permanent hardness. Just put
Okay.
No,
washing
Have you
soda
written
will be
down?
it's a permanent hardness is a double displacement reaction. There.
Exactly, it is
oh
a double displacement reaction.
just asking no heat is involved, right, sir?
No, here heating is not actually involved here.
Yeah, okay, sir. Yes.
Okay, so shall I move to the next page?
Yes, sir.
Yes, sir.
Okay, so we have discussed this. Then we have to study the reactions of water. Reactions of water. So can you tell me that if I'm having this water, what it can actually do? One of the thing is that it acts as a catalyst. Water acts as a catalyst. So can you tell me what is a catalyst?
Sir,
Water
Sir,
acts.
it
have
increases the rate of
reaction without taking part
reaction
in it.
or decreases.
Exactly.
without taking part in the reaction.
Most of the
Yeah.
time, catalyst will increase the rate of
Run
reaction,
a
right?
period and I think
Exactly.
Okay.
Okay, for example, I will write the reaction H2 plus Cl2. Hydrogen reacts with the chlorine in presence of water. Water acts here as a catalyst. So what will be the product? Will be twice HCl.
HCl,
Exactly.
2HCl.
So that means water here acts as a catalyst. Similarly, if I am having next reaction, for example, it is my phosphorus P4. The formula of phosphorus is P4. If I'm just
Yes, sir.
doing the oxidation of this, that means in presence of oxygen, it forms
PO4, phosphate.
P2O5, phosphorus
Oh,
pentaoxide, P2O5. Can you balance it twice and
twice.
5 times?
And
And
five,
here
five,
water
five, five,
also
five,
acts
five.
okay. So that means
Catalyst.
in these two reactions, if we are having moisture means water vapors. So water vapors will increase the rate of reaction. So that means water here acts as a catalyst. Got it?
yes,
Yes. Okay. Let's see the next reaction. Next reaction of water, that is actually a reaction with non-metals. Reaction with non-metal.
They are
Reaction with non.
halogens, right?
Okay, I will tell you. For example, if you are having this water and you are
hydrogen
just
is a
reacting it with with carbon in the form of coke, charcoal, etc. So can you tell me what will be the product? Water you are taking it here in the form of steam,
carbon dioxide and hydrogen.
not carbon
Hydrogen, hydrogen.
dioxide. It will be carbon monoxide and hydrogen. And now,
Oh,
can you tell me
okay.
what is this mixture known as? This mixture is very important, known as water gas.
Okay.
Can you tell me this
Oh,
water
yeah, yeah.
is used as a fuel?
Yes, sir.
Used as
You
a
are using
fuel.
that in what, sir?
Yes, it is used as a fuel because hydrogen is a fuel. Carbon monoxide is
Fuel
also the
in like car fuel, or is it like a specific?
It is used for car fuel. It's actually used for car fuel.
exactly we can use it. So this water gas you have to remember, this is very important because it will be asked in the exam. Similarly, let's see the reaction of water with chlorine, halogens, right? They are also your non-metals. So what will be the
Yes,
product?
sir.
One of the product will be
Uh,
HCl.
yes, sir. Press
HCl and O2. Sorry,
No,
sorry, HC.
HCl.
one is the HCl, that is
Oh,
hydrogen acid. Another
hydrochlorate.
HCl, HClO. This is known as hypochlorous acid.
Hypochlorous acid. Yes, sir.
Hypochlorous acid.
So it's in a book, sir.
Yeah, exactly. You will remember it.
First time
Okay,
book
then
is there.
let us see the reaction with metal oxides. Reaction with metal oxides. Reaction with metal oxides. For example, if I am just taking the sodium oxide, Na2O, if I am just reacting it with water, so what will be the product? This is very easy reaction. I hope you can do it. Product will be NaOH, that is base. Base will be formed, right?
Yes, sir.
Can you balance it twice?
Yes, sir. That's it.
Okay, if I will write now potassium oxide, what will be the product? It will be potassium hydroxide. So you can also balance it like this. So just write it. Now similarly, if I will write calcium oxide, what will happen if I will react it with water? Can you tell me the product?
Uh, mm, mm, calcium
Hydroxide, isn't it?
hydroxide. Oh,
This is actually known as
so that's it.
quicklime.
Calcium hydroxide. Okay.
Quicklime, and what is this known as? Calcium hydroxide is known as lacquered lime, right?
Slate. Yes, sir.
So just write it.
Yes, sir.
Have you completed?
Last
Almost
equation.
1 second left.
Okay, okay.
Yes, sir. Finish.
Okay, so then let's
One
see the
second, sir.
next.
1 second.
Yeah.
Okay, I will just go back.
E. E.
Completed.
Yes,
It
sir.
finished long ago, sir.
Okay, so now let's see the next. That is the reaction with non-metal oxides. Reaction with non-metal oxides.
So before was non-metal, now non-metallic oxides.
Yes, non-metallic oxides. Exactly. For example, if I am having just the
Ish.
sulfur dioxide, if I react it with water, what will be the product? Can you tell me? Similarly, if I am just
Uh,
taking dioxide, just there will be addition reaction. Do you know addition? That means only one product will be formed. So that's H2SO3
oh, H2SO4. I mean
and
H2SO3 and then
H2SO4.
H2SO4.
What is this known
First
as?
one
This
is
is known as
sulfurous acid. Sulfurous
sulfurous
acid.
acid. Exactly. It is known as sulfurous acid.
Sulfuric
Sulfuric acid.
one is,
And this is your sulfuric acid.
I was
Hey,
like,
Nitish, did you turn on your video?
I did for 2 seconds and then stopped because I'm eating.
Okay, next is very important. That is nitrogen dioxide. If we react nitrogen dioxide with water, what will be the product?
H2NO3 or
H2NO3.
oh
There will be
HNO3.
two
Okay.
products.
Nitric acid.
HNO2
Nitric
plus
acid.
There
Nitric
will be
acid.
two products. One is the nitric acid, another is your nitrous acid.
Ni- Nitrous acid. Yes.
Just write down these.
yes. 1 second.
Then is the reaction with carbides.
So carbide is 4 minus, right?
That means, yeah, exactly. Reaction with carbides. For example, if I'm having this reaction will be very important. It will be asked in the exam. So that's my aluminum carbide. That's Al4C3. So if you just react it with water, what will be the product? Can you tell me? One is the aluminum
Aluminum
Uh,
hydroxide. That is ALOH whole thrice.
plus
and then
Me-
carbide,
combined
hydrocarbon.
by
I mean C2. So C2H or
No,
like
methane,
ethanol or something. Oh,
methane.
methane. Okay.
Methane
okay.
gas is formed. This is very important. This reaction will be asked
Right.
because
Right.
next is
Okay.
calcium carbide. That is CaC2. Can you tell me here the product? One will be the
Maybe
calcium.
calcium hydroxide
Exactly.
plus ethane.
No, it will be C2H2. That is your
It's,
ethene.
so I was right, sir.
Exactly.
You
C2H2.
said
Okay, can you
ethine. You said ethine.
I said ethane.
it is ethene. ETHENE. Double bond is there. Carbon carbon double bond.
I said ethane. Okay.
Okay, now tell me how to balance these reactions. Can you balance yourself? For example, there are three carbons, so you will write here the three,
So
and there are four aluminum, so you will write here the four.
So
four
4.
here.
Okay, then can you balance
And
the
then
hydrogen and oxygen?
the
Hydrogen.
hydrogen is 7 on this
So
side.
12.
12, yeah, 12 times, exactly. It will be here 12, right? Okay, so can you balance this one? Is it balanced, the second one reaction? That is already balanced,
It's
right?
balanced. No, sir. Oxygen
C
is not balanced.
H
Hydrogen is
2
two
O.
times.
Exactly, you will
So
take it twice.
yes.
Yeah, two a two H2. Okay.
Okay, then aluminum nitride. Can you do the reaction with aluminum nitride?
So aluminum hydroxide plus mm,
That is
NO and NO. Yeah, NO2. NO2. NO2.
okay. First, I will write it. It is the reaction with metal nitrides. Metal nitride. These are known as nitrides. Above one were the
yes.
carbides. These are nitrides. So if I will just react it with water, aluminum nitride, it will form aluminum hydroxide. That is EL. OH whole thrice, and you will get the ammonia. That's NH3.
Yes, sir.
Okay, can you balance it?
So it's oh,
Thrice.
2O, 3H2O, and then everything else is balanced, I think.
Yeah, it is now balanced, right?
Yeah, it's balanced.
So have you
Okay, I'm
completed it?
writing. Yeah, I'm writing. So,
Okay.
Sir.
1 second, I'm
Complete.
still writing.
Okay, okay, okay. Just complete.
So we wrote a lot this class, sir.
Exactly, exactly. That's why I told.
Wait.
Have you completed?
No, sir, I didn't complete it.
Okay, okay, just completed. So that's why I told that this today's class it will be very important because most of the questions will be asked in the exam from this portion.
Yes, sir. So should I
Yes, sir.
whenever I write C2, H2 and all, should I explain its ethene?
It is not necessary because when it is C2H2, it's understood that it is ethene. But if you will write, that is preferred. That is better.
Oh, okay, sir.
Okay. Okay, okay. Now, let's
Yes,
see
sir.
another reaction here. That is my, if I'm just taking magnesium nitride. So can you tell me the product? Mg3N2.
Uh, Magnesium hydroxide
Exactly. And
plus
you
Magnesium hydroxide plus
nitrogen. Okay,
NH3. So
ammonia.
yeah, you can balance it like this. Similarly, calcium
Mm,
nitride.
so it's not balanced, sir. Not
Why?
how was
balanced.
it not bad?
So because there are
Oh
two
yeah,
hydrogen
3 MgOH
in
twice. Okay.
Okay. So in both these reactions, you will remember that ammonia gas is formed here, right?
So every
yes,
reaction with
sir.
metal nitrides, it'll end up like ammonia
Exactly,
gas.
exactly. Whenever there is any metal nitride, it will be ammonia will be your product. Then we are having gold, platinum, and silver. These are
These are
metals.
all metal. Okay.
What will be the product? Can you tell me the product?
Sir, AuH
Uh,
plus AU hydroxide plus
yeah,
H.
silver hydroxide plus hydrogen, maybe.
So this will be very important, and I hope that you will remember that no product is actually formed here. They are inert metals. They are
Yeah, I
noble
should have
metals.
when you wrote in red, sir. Red is
Wait, they're
bad.
noble metals.
Yeah, they are noble metals. I hope you will remember these: gold,
So
platinum,
noble
and
metals in the sense in their valence shell there will be 4 or
No,
8.
they're
noble
no
metals.
that
That
noble
they do not actually react
noble
with
metals
water.
that they have zero electrons in their valence shell or filled up
In
with
the
heat.
reactive. Okay, in the reaction. Okay.
Inactive
You
to
know,
water.
no, you know noble gases, right? You know noble gases,
Exactly,
right? They're
exactly. Just
not
noble
reactive.
gases are
Yes, sir.
noble gases are inactive. Similarly, these are also inactive. Correct?
Yeah, but noble gases
So,
have like
but why are
four
they
or
there in the reactivity series, sir?
They are at the last. They are at the bottom. Bottom means they are very least reactive. They are very least reactive. So
But
that's why we
gold,
say that they are
but
noble.
yes, sir.
okay.
But gold can still displace platinum, sir.
Yeah, exactly,
It's
exactly.
not
Gold can
necessary.
displace platinum, but this is actually here the reaction with water. All these three are inactive to water. You have to remember this.
Yes, sir.
So have you noted down this?
Yes, sir.
So we have completed the reactions. Then there are some pointers which you will remember. Number first is what is the density of water? I hope you remember. What is the density of water at 25 degrees Celsius?
It's a
I don't know,
hundred,
Then
sir.
it is
100.
1 gram. It is 1 gram
Oh,
per
one
Hundred
mm.
gram per
times.
meter cube.
Or
Oh,
you can
like
write,
that you're asking. Okay.
yeah, 1 gram per per centimeter cube. This is correct because sometimes it is
Oh,
asked
yeah,
what is the density of water.
centimeter cube.
Yeah, it is the same. But sometimes it is asked that water has maximum density at what temperature?
4 degrees
Oh,
It's
okay.
Celsius.
at 20, no, it's
At 4
31
degrees Celsius,
maybe.
water
Oh,
has
for, oh,
maximum
like
density.
animals
We have
tension of
already
water.
discussed this at 4
4
degrees Celsius,
degrees
right?
Celsius.
Yes, animal is
Yes,
expansion.
sir.
Exactly. Okay, okay. Now, question is asked that how is it beneficial to the aquatic life?
So, like more oxygen like
No,
dissolved in
see,
the water.
see. Actually, what happens in winter? In winter, water will freeze. It will just form ice layer
Oh yeah,
on
yeah,
the.
yeah. I read about this, sir. Like the
Yeah.
water will clear water will stay below the ice, so it will be
So
easy
this is
for.
my ice layer, and below this, water will be warm, right?
Yes,
Yes,
sir.
sir.
And this is actually very beneficial for the aquatic life. They can easily live in the winters, right?
Yes, sir.
Okay, next question is that which chemical forms the furring of tea kettle? Have you heard that?
What? Tea
What?
kettle.
Okay, okay, first write down this. Have you completed this?
Almost.
Yes, sir.
Just complete it.
Done, sir.
I'm still reading that.
Have you both completed? Okay.
Yes, sir. Finished, sir.
Done, sir.
Okay, then okay, what was my question? My question was that which chemical is responsible for
Oh, 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 oh. So 1 second, sir.
okay, if we are having tea kettle, there is some chemical which when actually put there is furring. I will explain it. What is this furring?
Yeah.
No, like those bubble things, sir. That one, right?
First, no, furring is actually it is the when a scale is formed inside the kettle. Scale. It is actually because of you will just remember the chemical. Chemical is your calcium bicarbonate. It is CaHCO3.
So can you tell whatever you told now again, sir?
I will again repeat it. Calcium bicarbonate. It is responsible for furring of tea kettle. Now,
What
what
is
is this
ferric?
furring of? Okay, okay, I will tell you. For example, okay, let's say this is my the inner surface of tea kettle, right?
Sir?
Okay, let's say something we are having like this. And now, when we just have this calcium bicarbonate, it forms a layer. It forms a scale here.
Yes, sir.
Yes, sir. Yes, sir.
Exactly. That is called the furring. That is called the furring of tea kettle. So this is
Oh,
because of this calcium bicarbonate. Actually, where is this present calcium bicarbonate? It is actually present in the
so it's present
hot
in
water.
temporary hard water.
Exactly, exactly. It is present in the temporary hot water. So
So
that's why
it's like,
sometimes
yeah, so, sir, so it's like when the tea gets very cold, a layer of thing is
exactly
present
there
on
is
the tea.
yeah, there is the layer present in inside the tea kettle. So that is called furring, and this is actually due to the temporary hardness, and it is actually due to the calcium bicarbonate. Correct?
Yes,
Yes,
sir.
sir.
Okay, next what we have to remember here that is the difference between air and water in the composition. So if I have air and water, so can you tell me in air which gas is present in large quantity? That is the
Oxygen,
nitrogen, right?
nitrogen, carbon,
Nitrogen.
nitrogen. Okay. Nitrogen,
Nitrogen,
oxygen, carbon
nitrogen is
dioxide.
58%, right?
Yes, sir. Oxygen
You
is
want
20
1%,
1%.
and carbon dioxide is 0.03%, right?
Yes, sir.
Okay, but in water, what is which is more, which is in excess?
Oxygen.
No, no, it is the carbon dioxide. Carbon dioxide is in excess.
Oh, okay.
This is very important to be remembered. So that means nitrogen and oxygen are in less amount or they are in less quantity. Will you remember it? This is very important.
Yes.
Yes. Then you will remember some
Sir,
salt.
actually, the other
Yeah.
class started, sir.
Okay, okay, but just I will take 1 minute. I will take 1 minute. Tell
Yes,
me
sir.
what is Epsom salt? Do you remember what is Epsom salt?
Yes, sir. Just.
It is the magnesium sulfate heptahydrate, right?
Oh, yes, sir.
Okay, next is what is actually your dolomite? Have you heard this name, dolomite?
No, sir.
It is actually your calcium carbonate, magnesium carbonate. Calcium carbonate dot magnesium carbonate. And have you heard the name potash alum?
Shalom.
Yes, is there any substance known as potash alum?
I don't know, sir.
I don't know, sir.
Okay, tell me
I
that.
didn't know that was a thing.
Okay, tell me that when you potash alum, it's actually put in the wells in order to purify the water, right? It is your potassium
No
sulfate.
idea.
It is okay. Okay, you will just remember first the formula. It is potassium sulfate, and then it is your aluminum sulfate. It is a double salt. It contains two salts in it, and then there is 24 water of crystallization here. Got it? This is known as
Yes,
potash alum. Have you gone to the barber shop? Barber shop
yes,
for
sir.
cutting? Yeah. Okay. What? Sometimes if there is cut in the skin due to blade, what we apply there? What we rub it with? Barber
Sir, we
rubs
put
it.
some
Alcohol.
yellow color thing, sir. We put some yellow color.
That is white colored soap. Like that is your potash alum. It is used
I
in
thought
the
it was
barber.
alcohol.
No, no, barber shop. In barber shop, they are using that soap. That is white soap. That is actually your potash alum. Like this. Got it? So
Yes, sir.
this was
Yes,
in
sir.
today's class, and I hope there is one more topic which you can study yourself. That is water pollution. Do you know what is water pollution? What is pollution? Can you define what is pollution?
So when something is polluted because of like
Exactly.
unusable.
Exactly. So you can say any undesirable change in the natural environment
Yes,
by any physical, chemical, or biological factors in air, water, land. So that is called pollution, right?
yes, sir.
Okay. So with this, we have completed this water chapter, and I hope that you will revise each and everything, and you will just go through the exam, and I hope that you will clear that, right?
Yes.
Yes, sir.
Okay. Wish you all the way best. Have a nice day ahead.
Thank you, sir.
Yes,
Bye,
sir.
sir.
Bye, sir.
Most welcome.